Good morning, students. Welcome to Operation and Maintenance of Solar Electric System class. In this, today we will discuss the topic called solar concentrators and effect of irradiance, temperature, shading on solar photovoltaic panel. Questions you can expect in the examination is write a note on solar concentrators. Similarly, one more question. What are the effect of irradiance, temperature, shading on solar panel? So that is solar concentrator. A solar concentrators are used to increase the sunlight, like intensity hitting to the solar panel. Like concentrator can be a mirror concentrator or the the concentrators like parabolic dish kind of a concentrator, whatever the concentrator, but the concentrator actually focus the sunlight to a particular area. So what happens means the irradiance it is coming to the solar panel will increases. So here normally we use the lenses or the reflective glasses used for focus the light. So actually it increases the power output by increasing the short circuit current. So cooling system, when as the solar system more sunlight falls means what happens immediately cooling is required. Otherwise normally standard testing condition they test at 25 degree. If you increase the sunlight focus the temperature goes very high. So that's why cooling mechanism is required. So we'll go for a diagram here. So in this diagram you can easily see these are all flat mirrors. So flat mirrors is focusing sunlight to the panel. Here what happens means the area of the sunlight increases, the catchment area increases. So this, so whatever the fallen sunlight it will be focused to the particular place. But here efficiency will never increase because efficiency is a product of power output divided by power input. So in this power input actually it is multiplied by area. So the efficiency will remain constant but the short circuit will current will increase. Next we will discuss what is a irradiance. The amount of solar irradiation. So irradiance we normally called as like the amount of solar sunlight hitting to the solar panel or cell. So whatever the sunlight hitting to the cell that largely determines the power output. So the power output of PV array can be estimated using the performance of data provided by the manufacturer. So the irradiance we calculate with the help of pyranometer. So normally 1000 watts per meter square is a standard testing condition. So if we take a solar panel, the rating of the solar panel will be kilowatt or watts peak. Say we are going for a 1.5 kilowatt peak power array. So that means that array will provide us at a peak power, that is at 1000 watts per meter square sunlight. It will provide 1.5 kilowatt per peak. So meaning means so when it is at standard irradiation, that is at 1000 watts per meter square, then it will provide 1.5 kilowatt. So as the sunlight decreases, automatically the current, or we can say that power output decreases. Normally I can say that, see from the graph, we'll check the graph now. You can observe that voltage will never decrease too much, but what actually decreases means, see if it is at 1 kilowatt, so this if you take it as standard, as the irradiance decreases 0.75, 0.5, 0.25, is the irradiance increases 1.25 like that. So irradiation directly affects with respect to the short circuit current. So similarly it affects the power output also, but voltage almost remains constant. A small little 1 or 2 voltage difference will be there. So we will see now the effect of temperature. So effect of temperature, the temperature plays a one interesting role here. As the temperature increases, here the power output means power output decreases, but the thing here is it will never play with the current, but it plays with the voltage. Why? Because as the temperature increases, the voltage drop across the cell increases, or I can say that the voltage drop there itself will increase, means the voltage drop finally what we get from the panel will decrease because of the resistance. So the voltage, open circuit voltage starts decreasing as the temperature increases. So at the cursor will show now at the temperature of 25 degree. If it goes to 50 degree, the open circuit voltage decreases. Similarly, if it go for 75 degree, see every degree increase in the temperature, normally we can classify that it will be around 0.5 voltage decrease. So this is what the globally they say. So if it is decrease in the temperature, so that also graph is available. So colder temperature, if the temperature decreases, automatically the voltage increases. This in India it is not possible, like less than 0 degree with a better sunlight in India it is not available, but in the colder climates like in the space, and there the temperature is very less as well as very hot sunlight will be there. So there if you are using more and more negative temperature, voltage will increase. Then the concept called shading. So shading is an important phenomena for the solar panel. Actually shading means it blocks the sunlight. So there also the types of shading will come. Uniform shading and non-uniform shading. Uniform shading means totally some clouds coming, all these things. But non-uniform shading means a bird coming on, sitting on the solar panel. Similarly, some buildings cross when the sunlight increase, sun is going to dusk. Normally, building side edges will fall, the shade will fall on the solar panel like that. So once that cell is shaded, automatically what happens means that will never produce the electricity. So immediately what happens means that will be, it will be load on the other solar cell, it is getting the sunlight. So that starts damaging them. Sometimes bird coming and sitting on that particular solar cell. So that cell will act like a load to the solar panel. Actually, it will be like all cells will be in series. So it will, we call it as bottleneck concept. So immediately what happens means that particular place resistance will increase and automatically it starts heating up. So that we call it as hot spot. So hot spot, if it develops for a longer duration, there will be a physical damage. So how to avoid this means you can go for a bypass diode. Thank you for today's session.